Today we are going to work on part 3 of our countdown to STAAR. So these are pages 5 and 6. So here it says Sarik is showing how to model the area formula of a triangle. So from our STAAR chart, we know that the area of a triangle is your base times your height divided by 2. So 1 shows the original triangle, 2 says create a congruent triangle and rotate it, then join it to the original triangle, forming a parallelogram. 3 says decompose the parallelogram into a right triangle and a trapezoid. And 4 says to rearrange the triangle and trapezoid to form a rectangle. So which of these steps will identify the area of the original triangle? So we're going to find the total area of the trapezoid. So that would be one option, finding the area of the rectangle. So area of a rectangle is area equals base times height. So that's close, but we have one more step in there. And find the area of half a trapezoid, or to find the area of a shaded triangle. So the shaded triangle means like these little triangles right there. Is that going to help us find the area of the original triangle? And B says find half the area of the rectangle. I didn't see that. So that would be dividing by 2, or area equals base times height times 1/2, which would be correct. Number 2 says that in Keisha's snack pack of crackers and cheese pieces, the ratios of crackers to cheese pieces was 12 to 8. How many times as many crackers as cheese pieces are there in each snack pack? So there's a 12 to 8 ratio. And what we're doing here is simplifying. What number divides into 12 evenly? That also divides into 8 evenly, and that is 4. 12 divided by 4 is 3, and 8 divided by 4 is 2. And then you can set that up as a division, so make sure to finish number 2. And then number 3 says Zachary drew the strip diagram below, and according to Zachary's diagram, which statement is true? So this is knowing the difference between fractions, decimals, and percents. So if we have 1/4, what is that as a decimal? It is 0.25. So think about it in money sense. If I have 1 out of 4 quarters in the money, how much cents do you have? 1/4 is worth 25 cents. So that's right, and that's right. And then a percent. So a percent is out of 100. So I have 25 hundredths. That's 25 hundredths. Write it like you read it. So that equals 25%. So that's correct. So then if I have 2/4, does my decimal and fraction stay the same? So each are represented by the 4th and the 25%. So according to Zachary's diagram, which statement is true? So if you have 4/4, that's 1, 2, 3, 4/4. Is that the same as having 0.4? So if you add up 4 of these, 1, 2, 3, 4, 4/4 equals 1 whole. So then that means that that decimal should be 1 whole. And your percent, if you have 1 whole, then you have 100%. So that's not correct. If you have 1/4, you have 0.25. That's correct because it's right here. And then it's 2.5%. No, it's 25%. Okay. If you have 6/4, so that's 4, 5, 6. Okay, so that's all of these. Okay, so is that 1.5? So we're at a 25, 25, 25. Well, here's 4 quarters, so that's $1. And then we have 2 more to go. What's 25 plus 25? Good, 1.50. And then to convert your decimal to a percent, remember Dr. Pepper, decimal to a percent, moving it over 2 times. So is that 150%? Yes. Okay, so we have one whole, but what did we say our fraction was as a whole? 4 over 4, so that's not right. So your answer is C. Look at the expression below and which equivalent expression, which shows an equivalent expression. So this is your dividing fraction. So you're dividing 2/3 by 1/4. When we divide fractions, we keep, change, and flip. So flipping the 4 and the 1. So you keep your 2/3, you change division to multiplication, and then you flip your 1 over 4 to 4 over 1. So then just identifying your answer choice there. And then number 5 says, Lucas wrote the expression shown here. Okay, so this is called the distributive property. Okay, and it says which shows the equivalent expression. So for distributive property, we go here and we multiply, and we go here and multiply. So this is our Oprah property where everybody gets a car. The T and the 5 get the 4, so everybody gets a 4. So operation is multiplication, so 4 times T is 4T. Then we have a plus sign. And then 4 times 5 is 20. So your answer is D. Number 6. Look at the input-output tables below. Which statement is true? Both represent an additive relationship. So additive relationship means we're taking x and we're adding a number to it. So that means we would take x, which is 2 right here, and we can add 2 to get to 4, which means that when you add, you're supposed to add by the same number. 2.5 plus 2, is that equal to 5? No. So that's not an additive relationship, so that's false. Both tables represent a multiplicative relationship. Okay, so multiplicative is you multiply by the same number to x. So right here, ax. You're multiplying a number times x. And you multiply by the same number. So 2 times 2 is 4. 2.5 times 2 is 5. 3 times 2 is 6. And 3.5 times 2 is 7. That's true. That's multiplicative. Let's pick a number. I can't multiply any of these numbers to get x. Like 4 times what equals 6? It would be a decimal. So this is not multiplicative. Oh, sorry, right here. That's not multiplicative. Answer C, only one represents a multiplicative relationship. That's true. And answer J says that they both represent. And we just said that they don't both. Okay. So going to number 1, on the back, it says, which model represents 2 times 3? So you have your multiplication. So you're starting at 0, and you have, this is 2 sets of -3. So how many times is taking you away from 0? 2 times, and then negative direction. So that's going to the right, which is positive. This is going to the left, which is negative, and it's 2 sets of -3. Number 2. Mike found that the simplified value of the expression below to solve a math problem. Okay, I know I haven't said this yet, but please make sure this is just a support system, that you have actually tried these problems first before you solve them. Okay, so if you haven't solved this yet. Okay, so first up is Pemdas. Okay, so we're going to do parentheses first, but inside the parentheses, we have our exponent. So 4 times 4, what does that mean? Good, it means 4 times 4. Sorry, no, I told you. 4 squared means 4 times 4, which is 16 times 4. So then we rewrite everything that we have. And then 16 times 4. It's 24, 4, 5, 6. So that's 64. Okay. And then your next step is to multiply because that's what comes next in our Pemdas. So 64 times 2, that's 8, and that's 12. So 28 minus 128. And then your last step is to subtract. One is positive and one is negative. So remember, when they're opposites, we're going to subtract. Which one's bigger? Do we have more positives or do we have more negatives? We have more negatives. So our answer is going to be negative no matter what. So let's set up our subtraction, which is 100. Okay, so we should have a negative and then 100. Okay. This one is talking about Denzel. It's going to make the design show on the right with the plastic trapezoid, and each trapezoid will have the dimensions shown here. So let's count how many there are. 1, 2, 3, 4, 5, 6, 7, 8 total because it said each. So this just represents 1. So if we go to our STAAR chart, we have area of a trapezoid is 1/2 base 1 plus base 2 times your height. Okay, so if we look here, your top number is your base 1 and your bottom number is your base 2, and this is your height. So area equals 1/2 1.2 plus 2.4 times your height of 1.2. Okay, so once we do all that, this is just for 1. How many do we have again? We have 8. So we have to take all of this and multiply it times 8. So if we look at our answer choices, there are 2 answer choices that don't have that multiplication, and that is F and H. Okay, so then just look at my plug-in and see which one is your correct answer. Okay, so then you have 4, 5, and 6 to complete. And let me know if you have any questions.